Okay, right, we're ready to start the fifth chapter in the order that we do things anyway. Moments. Now, I'm fully aware that some of you don't do physics and might not have come across this. I would have thought it would have been on the GCSE syllabus, but then again, I don't know. They do so little on that I used to do when I was young. So anyway, a moment is talking about a torque effect. Torque, torque. Okay, and what it is if you get a screw, for instance, it's all about leverage. If you put down, you try and screw it into the table, looking down on it, bird's eye view, and you put a lever here. Okay, what it is simply how it's worked out, how torque is worked out, is from your pivot point. You measure the distance in meters, obviously SI unit in meters, and you times it by, let's call that d meters, and you times it by the amount of force you're applying, and that has to be perpendicular, right angled. Okay, so the torque of that would be F times D, force times distance. The units are Newton meters. Okay, and obviously you can have a clockwise torque, and that's what this example would be. And if I pushed it in that direction, it would want to rotate it around that way, which would be an anti-clockwise torque, but it was still measured in Newton meters because we're doing force times perpendicular distance. Okay, now obviously you'll see that the torque will increase if they'll get a bigger distance out. I've got more leverage. Okay, and therefore as the distance increases, the force can stay the same, you get more torque. Similarly, if I apply a force here and increase the force, keep the distance changed, the increasing of the force will actually increase the torque you're having as well. Okay, the important thing is to remember that it is a moment, which is your F times D. The force had to be measured, the measurement from the pivot point, okay, the fulcrum, we used to call it, that's what its proper name is. It's perpendicular distance. So as this chapter progresses, if you've got, again, something acting like that, you know this distance, but the force is acting like that. Okay, the force acting like that, you're going to have to componentalize this force. And this chapter, I don't know if it's in this lesson or the next lesson, is going to come, might come across that anyway. So what you have to do is componentalize that force to a bit doing that and a bit doing that. Now you can see this bit of the force here. If I know a known angle, let's say this angle here is theta, then this component is the force times by its component cos theta, and that's acting in that direction, and this component of the force is the force times by its component is sine theta. Now if I fix this distance to be d meters, then you can see that if you've got no distance from the fulcrum, in other words this force is going right through the fulcrum, there's no distance, it's a distance of 0 from the fulcrum, so that's having no effect whatsoever. So the only aspect of this force that we need to worry about is the perpendicular force, the bit acting downwards. So if you know this angle here, then it will be F sin theta. If the angle you knew was here, then this will be F cos theta, so it will change depending on the angle you're given. Okay, but either way it is this component, so it would be the force F sin theta times by its perpendicular distance from the fulcrum, the pivot point, D. Okay, and that would be measured in Newton meters, the answer to that. Okay, right. As it says, after completing this chapter, you should be able to calculate the magnitude of the turning effect of a force applied to a rigid body, solve problems about bodies in equilibrium, and solve problems about non-uniform bodies. Okay, I'm just going to check that I've got this on record, so just bear with me a second. I'm scrolling up to there. Let's take a second because I'm not doing that again. Full screen off, click onto that, and yes, I am recording, just to make sure. Okay, full screen. Sorry about that. I couldn't remember whether I'd done it or not. Okay, so I can get rid of that. Right, back onto this. 5.1, you can find the moment of a force acting on a body. So the moment of a force measures the turning effect of the force on the body on which it is acting. The moment of a force depends on the magnitude of the force and its distance from the axis of rotation. So the second point here, the moment of a force F about a point P, the fulcrum, pivot point, is the product of the magnitude of the force, size of the force, and the perpendicular distance of the line of action of the force from P. So find the moment of F about P. I don't know. They haven't done a diagram here when I've copied these notes out. So if I did something just like this, a diagram, so if you just make this diagram here, and again, we've got a force acting downwards like that, size, its magnitude is F, and its distance here is, let's say, at 5 meters, and it's acting perpendicularly, and this point here is P. So we would say that this is a force times by its perpendicular distance is 5, so be 5F, and the answer will be Newton meters, and we have to give a direction. This is one to turn it in a clockwise, so Newton meters clockwise. Okay, must have a direction to it, and that would be the answer for that one there. Okay, so over the page. I don't think they come into any decent problems yet. Same thing again. Find the moment of F about P. Again, the diagram wasn't copied when we did these notes, so I'll just do this one here. Let's make up another diagram, and I'll do that diagram we did earlier. I don't know, a force acting oblique. Okay, so we've got this force acting like that at an angle of theta. Okay, right, again, we'll set this distance to be 5 meters. And this size of this force, we'll call it F newtons. So as I said to you, we're going to need to componentalize this. And the two components I can cut this up into is there would be a bit going down like that. And there would be a bit acting in that direction like that. Now, as I've said earlier, this component can be forgotten about. Okay, that component is acting right the way through the fulcrum. Okay, the force is acting right the way through the pivot point. So there's no distance. It is no distance from. We can't measure it from the fulcrum. So we can negate that. This one, however, we want, and the force F times its component. Okay, it's not in a pinch, so it is sin theta. That is the magnitude of the force. That is the size of the force. So to work out the moment, we just do the force times by its perpendicular distance, which is 5. Okay, and the units would be Newton meters. And as you can see, so that's the answer there. And as you can see, again, it is wanting to rotate it or turn it in a, sometimes these are called turning moments. Okay, it turns in a clockwise fashion, so clockwise. Right, okay, let's hope these questions get a bit harder, and they do, I hope. Let's go to the next page. Right, here we go. It says the magnitude of the force is measured in newtons and the distance is measured in meters. So the moment of the force is measured in Newton meters. We've talked about this before. Anyway, the diagram shows two forces acting on a lamina. Now, a lamina is just like a thin piece of paper. It's got no thickness to it, and it's going all on in this same plane, on this same piece of paper, all these forces. So what you are doing, a lamina, you are just looking down on a bird's eye view of this piece of paper. It doesn't matter how big the piece of paper is. It's asking us, find the moment of each of the forces about the point P. So we want to take moments about the point P. So find the moment of each of the forces. So the 5 Newton force, the 5 Newton moment, 5 Newton moment would be its force, which is, well, better write down the equation we're going to use, F times D. and it is its force times by its perpendicular distance. Well, luckily we've got the perpendicular distance there is 2, okay, and therefore it gives us 10 Newton meters. And again, as I've said, you want to quote the direction. It is wanting to turn this door handle as though this was a real door handle. It wants to turn it in a clockwise fashion, so clockwise. Okay, so here we go, that's that one done. You're then going to look at the 8 Newton force, and this is the distance or the measurement we've been given. So I'm going to componentalize it in such a way that we've got a perpendicular distance just there, and because we're going to need that one, and therefore the other orthogonal one is acting in that direction. This one we can forget about because it's acting right the way through the fulcrum, so it's having no effect. So I am now going to just concentrate on this one here. The size of the force is 8, so 8 newtons, times by its component. It's not in the pinch, so it is sin 50. So that's the only bit of this force that we need to worry about, and it's perpendicular, it's acting perpendicularly. So I know the 8 Newton force will have a turning effect, a torque effect of 8 sin 50, and we're going to times that result by 2 meters. That's what it equals, and on a calculator we end up with 8 sin 50, and we're multiplying it by 2, and it equals that, which is 12.3 Newton meters. But we now need to say also that it's wanting to turn it around this way, so it is anti-clockwise. Okay, and that's what we've got just there. Now, it didn't ask us for the sum of the moment, so what if this was going on, what this would feel would be the combination of this. So in other words, these notes are going to go further on, and it'll ask what is the torque or what is the moment that P is experiencing. Well, if it's experiencing that in a clockwise and it's experiencing that in an anti-clockwise, then they obviously cancel out, and you end up with an excess of 2.3 Newton meters in an anti-clockwise manner. So all this would feel here is the result, which would be a 2.3 Newton meter anti-clockwise, because this is the bigger one. Okay, but we'll come on to how we set that out hopefully as these notes progress. Oh, maybe not. There's the next exercise. So all I want you to do, or all they're asking you to do, is work out these moments. Remember, you're going to need to componentalize them if they are oblique. Okay, and there's the answers. Okay, I'll leave it to you.